Listening exercise 5. Passage 1. Page 193. Questions 1 through 3. Listen to a lecture in a biology class.
Here's a question for you. If you throw a seed on the ground, how do the roots of the seed know to grow down into the ground and the shoot, where the leaves will grow, know to grow up? The answer is tropism. Tropism is the preferential growth of one part of a plant toward or away from a stimulus. Positive tropism is growth toward the stimulus, and negative tropism is, of course, growth away from the stimulus. I'm going to get into the mechanisms of exactly how this happens on a cellular level in a moment, but let me just begin with some kinds of tropism to illustrate the general concept. To start with, let me make it clear that there are many different kinds of tropism and, as often seems to be the case in science, sometimes different names for the same thing. To simplify the introduction of the concept, though, I'm going to restrict myself initially to 3 kinds of tropism: phototropism, hydrotropism, and geotropism. Okay, let's start with phototropism. Photo means light. So this is when the growth of a plant responds to a light stimulus. For instance, the shoot and leaves of a plant would exhibit positive phototropism, orienting themselves in the direction of a light source. On the other hand, the root emerging from a seed might show negative phototropism, growing away from any light. Okay, so you can imagine this. Let's take a houseplant as an example. When you get it, say as a present for your dorm room from your family, it's nice and even, with leaves on all sides. After a few months, though, you start to notice that the side of the plant near the window seems to be fuller than the other side. It's got more leaves, and your once balanced houseplant looks lopsided or uneven. So what do? You rotate the plant, and after a few weeks it looks even again. But if you leave it, again it starts to be fuller on the side toward the window. Over the course of a few weeks, the leaves orient themselves to the light source, and you have to keep rotating it if you want it to look balanced, right? Okay, now what about geotropism? What do you think this is?
Well, geo means earth, so geotropism must be movement toward the earth.
Yes, growth toward the earth. It's actually uneven growth on different sides of the plant structure that changes the direction of growth, not movement per se. So where would we observe geotropism?
I guess the roots would show geotropism when they grow down.
Right. Or a shoot might exhibit negative geotropism, growing away from gravity. The stimulus in this case is actually gravity, not just the earth. I'm going to show you some pictures of these different kinds of tropism, and in many cases you'll be looking at pea plants. They're popular to experiment on because they germinate quickly, and these different kinds of tropism are easy to see. You'll be seeing some experiments with pea shoots to show negative geotropism and positive phototropism. All you have to do is turn some pots full of pea plants on their sides, and you can watch the pea plants bend and turn upward. In fact, they've been taken into space to see the effects of zero gravity and hydrotropism on plant germination and growth. And so this brings me to hydrotropism. This is the preferential growth toward water. If it's positive hydrotropism, that is. This is again something most associated with roots and easily seen in the pea plant. Yes, is there a question?
Is this how tree roots can tell if there are water pipes nearby and can grow into them and tear them up?
Well, not exactly. In spite of what many people believe, plants can't sense water from a few feet away or through the walls of a pipe. Plant roots don't grow toward pipes and tear them apart because they somehow know there's water inside. They might grow along pipes because they present less resistance than the surrounding soil. Or, if there's any kind of leak that moistens the surrounding soil, then yes, hydrotropism can act to draw the roots of a plant, but only within a few millimeters of the plant roots. Okay, so before we go on to chemicals and cellular mechanisms, are there any questions?